Hello, everyone. So, welcome to the wonderful session today hosted by InfoSec Girls. And today we have Shreya Pohekar with us, and she will be discussing about a very interesting topic, Kubernetes. So, about Shreya, I would say Shreya is a very enthusiastic and a good to go girl for us. And she's a great pen tester. She's a chapter lead for InfoSec Girls. And also, she's an Android developer. She's also a pro hacker on Hack the Box. So, Shreya, welcome and thank you for giving your time on this. Over to you.
Thank you, Shivani. So I'll just share my screen and please let me know if you can see it. Can you see it?
Yes,
Oh,
yes, we
okay,
can see.
okay. So the session for the today is getting started with Google Kubernetes Engine. So yeah, let's get forward. So who am I? I'm chapter lead for InfoSec Girls Bhopal and Null Bhopal. Also, I'm an Android developer. I also develop in Django and Python, and I'm also a penetration tester. And I blog about security on shreyapohekar.com. And you can follow me on LinkedIn and Twitter, and the handles are here. Um, so for today's presentation, since this is a very basic sort of presentation, means I'll cover the basic. So we'll start from the concept of virtualization and containerization. Then we'll move forward to what is Docker, and then we'll be going to Kubernetes and the Google Kubernetes engine, because this particular presentation will be based on like doing everything on GKE platform, that is a cloud. So yeah, and at last we'll be talking about the Kubernetes security practices. Also in between, I'll be showing some demo videos that are around the basic Kubernetes setup, like how you can deploy things, how you can run containers, and so on GKE. So yeah, what is Kubernetes? Kubernetes is an open source platform that helps you orchestrate and manage your container infrastructure on premise or in the cloud. So yeah, this time I'll be doing it on cloud, but it will be pretty much same when you are on premise. So yeah, it helps you orchestrate and manage your containers. So we'll see how it's being done if you are really not aware of the term. Okay. Um, So, okay, let's start from the beginning. So, from the very first thing, we are having virtualization versus containerization. Means we already had this technology of virtualization. Then why do we need containerization at all? So, virtualization, as we all know, it requires a guest OS for every virtual machine, a new virtual machine that we run. So, like I want to run Ubuntu or Windows or anything. Means if I want to run a simple server, for that I need to like deploy a new virtual machine, a new fully fledged machine. But the thing is, it takes up a lot of resources. Means Apache web server might have consumed just a few MBs, but like doing it on a like independent host, it will be consuming not more than it will be at least 1 GB. So that's a lot of resource for running a simple Apache web server. So here we got the solution for container that takes like if I want to run a Apache server, if I want to run a like SQL database server. So these all things can be run independently, but they will consume very less resources because we are in container, and the container allow us to like package everything into one single environment, and it will like run all the time. Means you take from one laptop to another, it will run there also. So that's the best part. So yeah, I have just included the site because um, I'll be doing it on cloud. So yeah, cloud is a on demand and service. So means like we do what we require, and we pay for that only. Like if I want a virtual machine for 1 GB, then I'll be paying for that only. So the resources are available over a network, means like the virtual machine that we run over VirtualBox or VMware, the same virtual machines are being deployed there, and we can like access it over a network. So it's like we can access it from anywhere. And yeah, pay for what you use. Okay, so that was it. Then now the Docker. So that's the important part. You need to know that. So Docker is a platform for developers and sysadmins to build, run, and share application with the containers. And the use of containers to deploy application is called containerization. So yeah, basically we are packaging everything, every library, every dependency into one single package that we call it a container. And the process is called containerization. So there are listed few benefits of why containers are useful. So as I already told that it's flexible, like even the most complex application can be containerized, like in very simple steps. And it's lightweight because it consumes less resources. It's portable as it can be moved from like one laptop to another without having any kind of difficulties. It's loosely coupled, like we have got, if we have got two containers running, both of them will be completely isolated, so like one has no effect over the other. Then it's very easily scalable, like it's always the requirement that does it. So if the requirement is to scale up, then there should be like it's smooth and nothing happens if we do such kind of things. So yeah, it's very easy to do and it's secure. Then a few more Docker terms. So first is the Docker daemon, that is the background service running, that is responsible for managing, building, and running distributed Docker containers. So the next one is the Docker client that talks to the Docker daemon, like we use the command Docker exec or Docker run. So that's what the command. That's the command line utility. Then the third one is the Docker hub. So Docker Hub is a repository sort of thing. Like we have APT, like apt in Ubuntu or Yum for rel. So in a similar way, that is a repository, a registry for Docker images. So it has got a list of all the images from where you can pull the one that you want for your requirement, and you can like further modify upon it. Okay, so you have embraced the container technology, but managing them at scale is indeed a bigger challenge. So managing them at scale means like running a one or two container is like very simple. But what if there are thousands of containers running? How will you manage them? So here comes the solution. And yes, you guessed it right, it's Kubernetes. So, what is Kubernetes? I'll be explaining again. It's basically orchestrating and managing your container infrastructure on premise and on the cloud. And it supports declarative configuration. That's the best part about Kubernetes, because in Kubernetes, you define the state for an object. So like I have defined that I have to create a Nginx web server and it will be running on port 80. So that is a declarative statement, a configuration, or you can say. And what Kubernetes will do is it will do anything to maintain that state. Means there are times when the container crash or like web the server has stopped working. So that is not the desired state in which I wanted my server to be in. So the Kubernetes will manage that and will bring my container back to the desired state. So yeah. The next thing is with Kubernetes, every kind of automation is possible. And the few use cases are like load balancing, logging, monitoring of every container that you have in your like environment, and scaling, obviously. And the last one is the imperative configuration. So in the second point, as I stated that there is a declarative configuration, but what if I want to change that desired state? So if I want to change that, I can use, means I can do that using the imperative configuration. Um, Okay, so features of Kubernetes. So Kubernetes supports stateless and stateful application. Means stateless means running an Apache web server or an Nginx web server, and stateful is where we are required to have persistent storage. Then easy scale and scale out, and workload portability means it's very easy if you want to move your like everything from on premise to the cloud or from one cloud provider to another cloud provider. It's very easy with Kubernetes. So yes, now we come to the important part. That's the architecture of Kubernetes. So the first in the first picture you can see is the Kubernetes objects. So objects are like we are defining the states means of different objects. So there can be various things that come under object like volume and different things, their name, label, namespace, and all that things that are all defined by us. Then the next term is a pod. That's an important term. So you might be thinking that container is the smallest unit that can be deployed, but it's not. It's the pod, and pod is a collection of one or more containers. So see, we discussed earlier that containers have got the property to isolate them so that they cannot communicate with each other, and means affecting of one container will not do any harm to the other running container. But there might be use cases where you are required to like communicate between the containers. So in that case, the pod gives you an environment. So in the second picture, as you can see that there is a shared networking and a shared storage. So this means that these three containers listed in here, they can communicate with each other, they can like share their storage with each other. So that's one of the best part. um, and yes, the example use case, as I already told, that like I have to run three Nginx containers. So that's how I'll be doing that. First, I'll be defining the states and creating the pods, and then it will be working. So yeah. So this is another slide with a lot of like terminologies, but it's the like heart of Kubernetes. So the first we have the Kube API server. So in this diagram, if you can see, there's a Kube API server that's like communicating to everyone in the picture. Like so, the work is here to authenticate the incoming request and like authorize them and validate them. Okay. And then we have a node. So first thing I wanted to clear that there is a hierarchy. Like if I go to the this one pod thing. So I told that the containers are like collectively working inside a pod. So but where is this pod running? So there we have a term called node. So as I was saying earlier, that virtual machine has its own importance, and container thing has its own importance. So here the pod is running inside a node. So a node is a virtual machine, and there are a number of nodes inside a cluster, as you can see here. So a cluster is a collection of nodes. A pod is a collection of containers, and those pods are running inside nodes. If I'm clear now. So
Shreya, can I request
yes,
something?
yes.
There's something on your right hand side, like export PDF in that window. Can we close that if possible?
No, I guess we can't.
Okay, there is a right side arrow. If you come down a bit, can you try and click and see if that works? Just come on the left.
This,
No, 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 no. Uh, Not
this.
extreme left. Not,
Okay,
yeah,
this.
this left.
Okay,
Yeah, this one.
okay, okay. Thank you.
No problem.
Okay. So the Cube API server, it like authenticates the incoming request and validates and authorizes the request. Okay. So we have the kubelet that is present on every node that is inside the cluster. So that kubelet is basically communicating with the master node. Okay. Uh, And then we have got the HCD. So HCD is the database for the Kubernetes master, and that stores the configuration variables or the environment variables or anything that is relating to storage thing, that all comes under HCD. Then we have got the kube scheduler that is responsible for scheduling pods into nodes. So scheduling pods means there might be places like you want a rollback or a upgrade. So in that case, I'll come that in the like upcoming terms. I'll tell that you are required to create replica sets. So those replica sets are being deployed, and then the deployment happens in such a way that um, the application is never down. So I'll just talk about it later. Then the kube controller manager manages means it continuously monitors the state of the cluster. So as I said, that the work of the prime work of the Kubernetes is to maintain the state in which the user desired. So that's the work of the kube controller manager. And for the cloud, Kube Cloud Manager manages controller that interact with the cloud provider thing. So that's it. And the kube proxy, this is when we are required to network. Like there is a Apache server running and I want to access it as a user. So I'll do that. So that happens all with the kube proxy. So yeah, here are some Kubernetes controller objects. So first one, as I was talking, is the replica sets. So like I have defined 100 pods that will run Nginx web server. So it will make sure, replica set will make sure that all are running at the same time. Then the deployment is the very important term. Like I said, it's when we are required to create updates or rollbacks or want to scale pods. So what happens is like there are three types of deployment. So I'll be just explaining one. So what happens is I want to move from version 1 to version 2. So like I don't want my server to be down in the meantime. So what I'll do is I'll create replica sets and I will move 30% of the pods to version 2, while the 70% will still be running on the version 1. So it will gradually happen, and then it will be like 0% on version 1 and 100% on version 2, and we like smoothly migrate between the versions. So that's how it works, and it's very, very useful term. Then we have got stateful sets that is basically dealing with the storage thing. Then we have got the daemon set that is like the work is to make sure that if I want any container to run all the time, means it should run all the time. So that's what daemon set does. Then we've got the job controller. So it's very, very similar to the cron job thing. So if I want that particular container should be up at this point of time, then the job controller will be managing all of that. Okay. So that was controller objects. And I think this is the last slide with the theoretical things, and we'll be moving with the demo, and you will be better able to understand what all these terms was. So the last thing is the service is where I'll just read it. Service in Kubernetes is an abstraction which defines a logical set of pods and a policy by which to access them. Means, see, we got a lot of hierarchy, means cluster, then nodes, then pods, then containers. So means, did you see any way by which I can access any application that is running on that container? So all these three things, the cluster IP, node port, and the load balancer, are the three terms that make that possible. So cluster IP is something when you want the container in one cluster to talk with the container in very some other different cluster. So yeah, as of now there was no communication at all, means the containers or were like isolated things. Okay, but now we are enabling some sort of communication so that like the reason can be anything, it's just the business requirement or whatever requirement or anything that you are building up, it's the requirement basically. So whatever you need is like Kubernetes has got your back, and it will really make everything very like possible for you. So yeah, cluster IPs for internal communication. Then node port is um, node port and load balancer. I'll come to the next slide, which will explain it a bit more accurately. Like, see, the traffic is being directed to separate VM in case of the node port, which is the second diagram. And for the third diagram, that is the node balancer, we are having a single node balancer that is like acting as a proxy, and it's like the definition of the node load balancer says that it's balancing the node, means whichever port is available, the traffic will be like gone to that port, sorry. So I hope these pictures make sense. And if you want to refer, there's a link from which I got these pictures, and they were really, really nice. So yeah, so to the demo part, I'm having, okay, you might not be able to see my screen. So I'll just do just a second. Mm, okay, can you see my screen now?
Yeah, we are able to.
Okay. So okay. So this all thing is being done on Google Kubernetes Engine. So if you have an account for course era, you should really check out architecting with Google Kubernetes Engine, and you will get a free access to Quick Labs. So it's really handy, and you can really learn everything about what's in GCP, Google Cloud Platform. So okay, so here we can see that the lab is for 1 hour. So everything or anything I do in that 1 hour will be wiped out. Okay, so yeah, um, so we open the Google console, and we are required to log in with that credential that are provided. So that will also go after 1 hour. Okay. So it's like you work here or you make a virtual machine, it's all same. Okay. So that's the dashboard, and that's the cloud shell. So instead of doing everything like connecting from your like host machine to the machine in the cloud, you can just spawn up this cloud shell, and it will give you the very same environment to work on, and it's really very good. So I didn't actually find that thing good, like to connect with the host machine to the virtual machine that is deployed on GCP. So yeah, okay. So now what we're doing is, since this is GCP, we'll have to export the zone thing, and that is US Centrally. It can be anything that is offered by GCP. Then we are exporting the cluster name that will be standard cluster one in this case. And then what we are doing is we are creating a cluster. So the very first thing is to create a cluster. So there's gcloud command, we use that gcloud container cluster create. Then we are creating 3 nodes in that cluster. Okay, and then enable IP alias means we are using private IP addresses. Okay, VPC native. So this thing takes like 2 or 3 minutes, but I had paused the video, so it won't take much time. So everything start with like creating cluster, then creating nodes inside that cluster. So in this case, it's 3. And then we create the pods. Okay, and then pod run those containers. Okay. Okay. So we have a cluster created with the number of nodes equal to 3. So that was the CLI way of like creating a cluster. But if you're not comfortable with CLI, there's obviously a GUI counterpart. So you can obviously go around and like do it graphically, but I like CLI. So yeah, now we can see that three nodes are running. So I'm sorry, that's a video. So okay, so the next part we are doing is we are like this demo basically is demonstrating a lot of different commands that we can use in GCP and GKE. Okay, so now we are doing is initially we were having like three containers, but now I'm changing. Oh, sorry, three nodes, but now I'm changing those nodes from three to four. So that four can be anything, any number. So like it's just a matter of one command and you are able to like change the number of nodes that you have in the cluster. So yes, since it's creating a node, it will again take a bit of time. Okay, so that is created. And yes, these things get credentials that we run because we want to tell the Kube API server that there is a standard cluster one running and we are in that context. So take everything in the standard cluster one context, because as of this demonstration, we are just having a single cluster, but in the enterprise environment, we might have a lot many. So we need to tell the context to the Kube API server while communicating. Okay. So that will happen in a few commands. Okay. So yeah, that's the um, configuration thing. So you can see that the cluster and the name and the servers are all listed. So that was .cube config file. And there is another file as well. Yeah, here. Here you can see after the get credential thing, a lot of things were populated in this config thing. But you can see that certificate authority data, that's one of the like secret things to have that is not being listed here. It says data omitted. So when you are in the like cloud platforms, the cloud providers like automatically manages that for you. So a few things are being secured for you, but yeah, we'll talk about that later. So yeah, there's a lot of information about all these things that happen. Okay, so then we can use commands like cluster info to view the like details. These are like um, viewing details about anything that you have. If you have nodes running, if you have pods running, then you can run those commands to view all the specifics or the details. So yeah, see, now we have like upgraded the number of nodes and the cluster size has now become 4 and previously it was 3. So you can see how easy it was to do. So next thing. Okay, so see the current context, like the context with which we are talking to Kube API server is the standard cluster one. Okay, and the first thing is the project name. Okay, so that's randomly being generated as of now. Then, yeah, another command to view the same information, just a bit like well organized. Then yeah, if you want to switch between context, you can use this command, use context, and you can just write the context name. Now we are listing the nodes, all the nodes that are running, the memory they are consuming. So as of now we have 4 and they are consuming these amount of like bytes. So that can be done with cube ctl top nodes. Now this command source kubectl completion bash is like for the tab completion. So like we have it in bash, we'll now be having it in kubectl as well. You can see that I wrote kubect, so it's giving all the like suggestions. Okay. So now with this command, we are creating a deployment. So it's a very basic command because we are not like putting up anything. So what it's doing, it's creating a deployment and it will pull an image of Nginx from the repository, the registry of images, and it will create a web server. So that was like very basic, but in the enterprise, this won't be happening because like obviously we just not only simply want to create a nginx web server, we need to do a lot of things like permissions and all different things that I'll be covering. So yeah, it's just the demonstration that how you can create a deployment or how you can get your pods running. Okay, so we are like exporting the name so that we can use it later. Then okay, so that was all the logs, like what happened when I ran that command to create a deployment. So firstly, it pulled the image nginx, then it created the container nginx, then it started the container nginx. So it's like happening automatically just with a single command. Okay, so now the like container is up and running. So now just we need to test that if it's working or not. So it's like creating a test HTML file, and we are now not inside a pod. So we'll use this command kubectl cp like we use docker cp. Okay, to copy the file from our current directory to the pod. Okay, so there we are using the name my nginx that we defined above, and we are putting it into the root directory of the nginx server. Okay, so that basically copies it to the container. Okay, so here is another an interesting command because as of now my nginx container was like it was isolated, means no one can communicate. But with this command, I am exposing the port number 80 using the type load balancer. So now when I do this, I'll be getting an external IP so that I as a user can be able to connect with the uh, Nginx pod. So means I'll be getting a web server. So as you can see, I have written here kubectl get service, but I'm not getting any external IP here because it takes a bit of time to give the external IP. So yeah, you need to wait 2-3 minutes, I guess, and then you'll be getting here a external IP. Okay, so now we have got the public IP for the container, and when I do write that IP, what happened? Okay. So see, there's some problem with the video. So as you can see that hello world was clearly visible, means it's publicly available now. Okay. So yeah, you can also list the pods that was done at the end, means the pod and the container is successfully running and I'm able to create a test file that's successfully accessible as well. So that was the end of the first video. The second one is the same thing that I'll be doing, but this time we'll be doing it with the YAML file because as I already said that doing things with command may be good, but not while creating or deploying things because we need to configure a lot of things from configuration to like security and everything. So that will require a lot of parameters, and doing it in a command will be like 2 to 3 lines long. So for that we create YAML files, and let's see how to do it. So that was a GitHub repo that I found, and it's publicly available by Google Cloud Platform, and it has a lot of lot of YAML files and a lot of YAML snippets, I would say, that are around various topics around Kubernetes, like how you can do this, how you can do that. So uh, you can like experiment with those small files and you can create a big one of your own, means according to a requirement. So yeah, should really note this repo down. That's really a long file. Okay, so that is done. So this is just creating links so that it's easily accessible to directories. So we'll cd into that, and there is a YAML file for creating the same Nginx web server that we created just now using a command. Okay, so here's the file. So you can see like very minimalistic specifications here, like there's a name, label, containers, and image, and port 80, means same that we did the last time using a command. So there's a command called kubectl apply -f, and we do that to a YAML file and our pod gets created. Okay, so that's the thing. So with apply you are doing the declarative configuration, but there's another command called create that does the imperative declaration, means if you want to modify something, then you'll be using the kubectl create, while if you are doing it for the first time or you want to keep it the same, then you'll be doing the apply command. So see, our pods are being created and they are up and running. So yeah, there is a command kubectl exec it, like we have the docker exec it command to get into the container. It's the same, just the kubectl is the new term. Then now we are inside a pod. So previously we created a text file and we were using kubectl copy command cp. In this case, we directly got into the container only, and we'll be going to the root and we'll be creating a test file. And same thing, test.html, and we'll be exposing the port. So I just increase the playback because it's too slow. Okay, so we created a file. It's like, oh, I changed because to create some difference in the text. Kubernetes is fun, and it really is. Okay, so it's done in the container now. Like outside the container, we need to run this command. Like port forwarding, we can also do like this. So it will be on the internal IP only now. So when we run HTTP 127.0.0.1 and that port, so we'll be able to access that test.html. So this was the internal thing, means there is no means we have not exposed the service, means the Nginx service to the outside world. It's just internally working there. Okay, so the last command was for logs, because there are a lot of containers running and there should be something to monitor them. So Kubernetes gives you an advantage to monitor all the containers that are running, and it's obviously helpful in debugging it in case of any kind of errors. So there's the third demo that I'll be doing about scaling in and scaling out. So let's see how it's going. So every time I do anything here, it starts from creating a cluster. So every time we need to like export variables and do all the same commands like create cluster and all that, and inside that create nodes, then pods, then the work that we want to do. Okay, so it's nothing new. So here we'll see that when we get a lot of traffic, how it automatically scales in or scales down automatically in case there is like minimal traffic. Okay, so yeah, again, we are going to the GUI window and see that the cluster size is 2 and the cluster is created with the name standard cluster 1. Then again, we'll be doing a git clone because we'll be requiring 2 YAML files from the same. And you can note down that GitHub repo. So that's the auto scaling module where we'll be using the 2 YAML files, one for like creating the web server, Nginx, and the second one will be like uh, creating load, means it will be creating request in a loop. So yeah, we'll be using one bot to do that work for us. Okay, so here we are using the create command and save config. So that is the, and yes, we have used the node port thing to make a deployment and we are exposing the port. So the next command is to get the web service. And here is the cluster IP. We've got the ports being mapped because it was defined in this web.yaml. So you can check it out. I don't have it in this video, but you can later check it out. Okay. So as of now, we have got just one deployment, that is our Nginx server, and you can use the command get deployment to do so. Now we are like we are creating a deployment with max 4, means we can have 4 maximum pods. So as of now, the available is just 1. Okay, as you can see now, but it will turn out that later it becomes 4 here. Okay, so yeah. Hmm. That are again different commands that kubectl offers. So yes, see, max replicas can be 4 and minimum is 1. That's the thing it's running. Means according to the load, it will like scale up to 1, 2, 3, 4, and from 4 it cannot move any forward because we have defined here. But it can obviously come back down when the load reduces to 0 or like minimal. So yes, now we are doing a loadgen.yaml that is basically um, that's basically creating load, means it's creating traffic on the web thing. Okay, so we have created another pod and those are 4. Now see, you can see here 1 on 1 means only 1 is available as of now. So still it's 1. See, so as of now these load gen thing is created. So it's created means the traffic has started to increase on this particular pod. So like I'm running this command again and again because it has still now not scaled up. So it will do it gradually. And now you can see that all the 4 web things are engaged, means all the 4 pods are now up and running because the one was not able to serve the request that the load gen pod was creating. Okay, so now we are scaling these replicas of LoadGen to 0, means now we are totally removing any kind of traffic that was being generated by this LoadGen pods. Okay, so we'll gradually see that the web pod is also like scaling down from 4 to 2 to one. Okay, so that was about this particular thing. I just wanted to demonstrate how easy it is to scale up and scale down with Kubernetes. So that was the demo part. So as of now, I never talked about security, and like presenting in an infosec community, I should need to talk about it. So here is for the Kubernetes security. So yeah, there are various things that we need to take care about while we are doing such things, because like I said, these YAML files, the file that are uh, get the contents of, it was very basic, means it was just pulling the image and like exposing on port 80, but it's not that really simple, because in enterprise we need to take care of a lot of things. So this was a high level overview where we need to manage authentication, authorization, admission control, encryption, and network policy. So I'll be talking about a few. So like the thing we had here, admission control. Like, what if I have the permission to access the pods, but then if I have the privilege to access the pod, what should be my privileges? Means I should never have a root access to the container, because then in that case I can like escalate my privileges to, means I can even escape from the container environment and I can take over the um, cluster even, and means lateral movement is possible in that case. So there are a lot of things that we need to take care about while we are defining security policies. So that the what security policy that comes under admission control, means once you are into the box, okay, authentication and authorization, they remain the same, means who are allowed and what they are allowed for. Okay, so then the network policy, like we were talking about service and cluster IP and node port. So we want our containers to be accessed in a particular way, means I don't want that this particular range of IP should access my containers. So I'll define rules in such a way that only this particular IP can access or this IP cannot access. So that are ingress and egress rule for Kubernetes. So that can also be defined, means I can also define that to which IP my container can communicate to. Means that's the to and fro thing. So ingress and egress thing. So yes. So security best practices. Yeah, the best practices always remain the same, but yeah, still it get ignored. So it's very important to take uh, always whenever we have these kind of sessions. So yeah, first of all, like what is the end goal? The end goal is to create containers, and in that containers we'll be obviously pulling images from somewhere. So those images should means always be from the official source, because they are much trusted. Means we cannot totally trust, but yeah, means it would be like they wouldn't be malicious sort of thing. So always download from official source, then use latest image and update periodically, because obviously like if you are running a old version, then obviously a CB is possible, and then your whole thing is like under some sort of, you'll be, means you can compromise any, means you can get compromised anytime. So update updation of things is really very necessary. And the third point is a good one. You can use image scanning tools for any CVs or vulnerabilities, because see, I was always talking about Nginx and thing. So that is just one thing, but there are a lot of services running in enterprise, and it might be the case that a few get skipped and you are still running the lower versions. Means there is the conception that I have heard that people don't tend to upgrade things because they break things while they upgrade it. So Yeah, means that's for like dev thing, because they need like every sort of experiment first, so that everything is fine and perfect, and then they'll be upgrading to the higher things. But yeah, um, things might get missed, so I found a tool, a clear scanner. It was a really good tool. Means you can scan it for images, so it will really tell you that images are updated or not. Means if it has got any kind of thing that is not updated, or it's working on a low um like low version, so it will like tell you. And it has got a like dashboard sort of thing, and it gives you scores on different thing that this can be exploited, so you need to fix this. So it's very good. It's the GitHub link is here, and you should really check it out. um Similarly, okay, so that was the image thing. Means the thing from which you'll be creating your whole application, that should first be the perfect one. But in case if that is not, like the Nginx server that I was running, it was like insecure, sorry. So what if the things that I'm running are insecure? So for that, you need some kind of security context for pods and containers. So what happens is, even if your application is not like perfect, you can use security controls to like control all of the, means you can decrease the surface attack. Okay, like one of the example is run as user. So here it's not a root, it's some user, which will be a less privileged user than the root, obviously. So the thing is, even if your container gets compromised for some reason, you means the attacker won't be able to do lateral movement. So this is just one of the specs that is mentioned. So there's a lot of things that are mentioned here. So the YAML files can contain a lot of specifications with which you can like restrict the things that the users can do. So that would be really increasing the security. So there are a lot of points that I've mentioned here, that take care of the UID, GID, should always use SE Linux. Then Linux capabilities is the very important point, because I recently saw a post by Riaz. So it was some CVE where the like we were able to force the packets, the network packets, and that was leading to the exploitation. So yeah, that was because there was one capability that was being um, given. So if you are able to compromise, then you are able to do lateral movement as well. So there are certain things that you always need to take care of while you are writing all these things. Okay, then obviously allow privilege escalation should be set to false. And that app armor that you can see there, so it does the um, security measures on the runtime. So here I've got one screenshot of how the this looks like. Means this the configuration for app armor. So it will do that at the runtime. So that's that. Okay. So yeah, then we should use secure persistent key value storage. So that's one another important thing. So what happens is, like I was exporting the variables under names. So that should not be done. You should really use secret managers for all your stuff that you think that is secret or should be secret. Like that can be anything: tokens, API keys, username, passwords, anything. Means you should always use secret managers so that everything is secure. Um, yeah, so means you can use Vault by HashiCorp. So that's open source, and you should really try it out if you have not. So yeah, so that was the end of the talk, and the references were basically from the course era. So Yeah, I know if you don't have the account, you won't able to find it, but it's like no need to worry because the next reference kubernetes.io has got everything covered, means it has got very well explanation of everything. And yeah, means you just need it all. So thank you. And if you have got any questions, you can really reach out to me on Twitter. And my Twitter handle is @Shrapohekar. So thank you very much.
Thank you, Shreya, for the wonderful session. And I hope the viewers also enjoyed this.
Yeah, I hope so. And yes,
And
if you've got any questions, you can like
yes,
put it in the comment as well.
definitely. And viewers, if you have any question, reach out to Shreya on her LinkedIn profile. She would be happy to help. Connect with her on Twitter and LinkedIn both. Thank you. Thank you so much, Shreya. Thank you, Vanna. And thank you everyone for watching.